All right. Good evening, everybody. Thank you very much for being here tonight. I'm really excited to tell you a little bit about the topic that I've been explored and that I prepared here for you, which is, as you can read, JavaScript for IoT. In particular, we're going to explore how, by using JavaScript, we can actually start experimenting with IoT devices. So let's jump right in. Let's talk a little bit about the agenda. So to begin with, obviously, we're going to talk about IoT. We're going to see what it is and what we can expect from it for the future. Later on, we're going to talk about Johnny5, which is a JavaScript framework that I use for these experiments. Following, we're going to talk about the hardware of choice, which is the Tessel 2, a small SBC, or single-boarded computer. And finally, we're going to see the experiments as well that I performed. Okay, but actually, before continuing, let me just introduce myself, maybe. So, hello again. My name is Stefano, and I've been living here in Japan for a year and a half now, and I am a graduate from Code Chrysalis 9th cohort. CC9. And yes, I am Italian, as I mentioned. Although I come from a small village from the mountains, and as such, my village actually looks much more similar to Switzerland than it does to Italy. And I don't have a technical background. I'm a linguist myself. But I like to say that I've always been involved with technology all my life, since I was a kid. That's particularly because my father is a software engineer. And as a kid, I always wanted to become like him one day. But growing up, you hit your youth and you start to want to be someone different. And hence, I started traveling around the world. So I was actually a backpacker. And I learned how to speak in different languages. As you know, I'm a linguist. So after 4 languages, and the 5th one coming, which is Japanese, maybe one day, and traveling every corner of the world, I decided that I wanted to learn how to talk with computers as well. Hence, I decided to take Code Chrysalis cohort. So yeah, now you know me a little bit better. Let's dive right in. Let's talk a little bit about Internet of Things, or IoT. And maybe we can start with this question. So, what is IoT anyway, right? So, if you look on the internet, there are many different definitions of IoT. But in general, we can all agree that it is any device that is connected to the internet and that can be controlled through another device. So, technically speaking, they are connected to the internet so that they can be better and help our life to be better as well. We can divide IoT devices into 3 categories. The first one are devices that can analyze their surroundings, and then they can send this data, collected data, through the internet. For example, I don't know if you can see it here with this white background, but anyways, this is a thermometer. So it's a thermometer that checks your body temperature. And in particular, this thermometer, after check your body temperature, will send this data to your phone, where you can see the history of your health status. Or else, as well, you can send this data to your clinic, so that your doctor can actually know how you're doing. Then obviously we have the devices that can receive data from the internet and then they can perform an action out of it. Take, for instance, a 3D printer. So a 3D printer like this one connected to the internet rather than to a cable and a computer. I know this might not sound as exciting as this other one that I presented before, but think about this. A 3D printer like this one, well, a little bit better than this one, it's actually on board right now of the ISS, or International Space Station, and it's orbiting Earth around 450 kilometers above our heads. So why is it there? Well, astronauts need to perform very specific actions in space, and not always they have the tools that they need. So what they do, whenever they need a new tool, they actually ask the people at NASA on Earth to send a blueprint to this 3D printer. And in a matter of seconds, they will be able to upload it and send it to this 3D printer, and then print it and perform the actions that they need to do. And finally, obviously, we have IoT devices that can actually perform both of these actions. So analyzing their surroundings, and send this data through the internet, and also receive data from the internet and act on purpose. For instance, in this case, as you can already see, a self-driving car. So self-driving cars have sensors around all of the vehicle that can help them navigate in their environment, and they can also send this data to a data center to the internet, so that it can be used from other self-driving cars. And also at the same time can receive data from the internet and that maybe can help it decide which is the best route to take in order to take us to the safest location, to our location, the safest way. So okay, we've seen these three categories, and how about we talk a little bit about the future for IoT? So, IoT forecasts. So according to Statista.com, as of today we have 26.5 billion devices connected to the internet. And still according to the same website, by 2025 the number will skyrocket and will triple. And we will have about 75 billion devices connected to the internet, generating a market share of 750 billion US dollars, which if you ask me, is a lot. And obviously after seeing all of this data, I asked myself, so what it is needed then to become an IoT developer? So, as of today, if you want to code or you want to develop an IoT device, you can do everything from A to Z by using one of these three languages. So, C, Python, and Java. From A to Z. But obviously, I mean, the language that I know the most actually is JavaScript. And so I asked myself, is there anything that I could do with JavaScript maybe? I want to do the same thing that I can do with those languages. Can I? Obviously, it is a rhetorical question. You all see the topic of my talk, which is JavaScript for IoT. Hence, let me introduce you to Johnny 5. Johnny 5 is the framework of choice that I'm using this time, and it's a framework for robotics and IoT. And in particular, this is the actual definition of it, which is Johnny 5 is an open source Firmata protocol-based JavaScript framework. As open source, obviously, as you know, you get access to the source code, then you can get access to it, you can use it, you can modify it. Firmata protocol, basically means that it's actually based on Firmata protocol, which is a protocol allowing communication between microprocessors and software on computers. And finally, it is a JavaScript framework, so obviously it is a set of code already there that you can call inside of your program and you can use in order to perform actions in a faster way. The beauty of Johnny 5 is that it's thanks to this Firmata protocol, we can actually run it on all Arduino models. We can run it on a lot of SBCs actually, which stands for single board computers. Not only on all Arduino models, but also we can run it on Raspberry Pis, bigger board, and Spark Fun Red board. Well, more of these actually. This is not a complete list. There is way more than that, and I actually suggest you to go on the website to explore and see how many other boards you can actually use this with. And why actually this? Well, Johnny 5 is here to help write programs for single board computers in a much more familiar way, especially for web developers like myself. And with this, I obviously want to show you a little bit of code taken from a Johnny 5 program, so that you can actually see what I mean with this. So here you see, this is a program written with Johnny 5, and this is actually helpful. It's going to run a very simple code to blink an LED every 500 milliseconds. Pretty simple. As you can notice, if you have familiarity with JavaScript, you can already notice some of the typical things you can see in JavaScript. But here we declare the dependencies, so we are requiring Tessel, which is the Firmata protocol, and we are requiring also Johnny 5, so the actual framework. Here we actually declare a new board, a new constant variable board, to which we assign an object coming from the Johnny 5 framework. Inside of it, obviously, we're telling it to mount the Firmata protocol for the Tessel, so that it actually knows it's a Tessel, right here. And then obviously down here we have the actual method that will run the program. So the on method actually accepts two methods, two parameters, excuse me. One is ready when, so it actually tells it to run the following function whenever it's ready. And instead of this function, we are obviously assigning to a constant a new object LED, to which we are telling it which door, which port to send the energy to. And finally, the method. So blink every 500 milliseconds. Whoop. Okay, we got through this. And if you do everything correctly, at the end, the LED will blink. So let's compare it maybe with some other language. Let's compare it with C++ here. So just running real quick, here we have the setup function. In here we are telling it to that the output for this, in this case, would be the pin port at 13. And then we have the loop. Here in the loop function, as you can tell already, we have two other functions. We have digital writes and delay. Digital write, the first one will send energy to the port 13, and the second one will take the energy out. And the delay, well, the delay actually stops the program running for 500 milliseconds. So this is how you obtain the same effect that you can obtain with Johnny5. Well, now that you can look at it from here, you can kind of tell that they are not so different. And honestly speaking, well, they are both actually understandable, right? So why actually going through all of this effort into writing in Johnny5 when you can obtain the same with C++? Well, it is true that they are similar and they are very understandable, but what happens when you write something more complicated than this? For example, I would like you to focus on the C++ section. I'm going to change the slide, and here is another piece of code that does something different. Here we go. So, as you can tell, a lot has changed. This is the code to pulse a light rather than blink it. And does anybody notice anything different in the Johnny5 section? Let me give you help. There you go. That's it. That's all you have to do to have a different action performed with the Tessel than in the C++ takes a lot of time to write. So just like this. Blink, pulse. That's it. Very easy. And well, let me give you a little bit of a disclaimer before I continue. If anyone here knows how to write code in C++, please don't hate me. I'm not here to diss C++. Honestly speaking, C++ or C are coding languages that are actually better at writing code for IoT. Johnny5 here is actually a framework for web developers or for anyone who would like to get into IoT programming without having to tame beasts like C++, honestly, which is not very user-friendly, or not very beginner-friendly, if you allow me. While usually JavaScript is far more accessible. So okay, but still, yes, performance-wise, C or C++, they kill Johnny5, so please, okay. Okay, let's move on. Let's talk a little bit about the hardware. So here we are talking about Tessel 2, and in particular, here you can see it. This is the Tessel. I have it here right now with me. Later on, we're going to show you a demo with it. It's just hidden for now. But this is the Tessel. And why the Tessel in general? Well, I decided to choose the Tessel because it has been built specifically to use with JavaScript. So it performs better when running JavaScript. And so we can actually distinguish it a little bit. So we have a connectivity and power input over here. We have two USBs, an Ethernet door, and a USB Type 2, where you can plug your power. Over here we have about 20 input-output pins, where you can connect your modules. And finally, over here, we have obviously the core hardware. So we have the microprocessors over here, 500 megahertz of power, very powerful. About 64 megabytes of memory. And we have a microprocessor as well to help with compiling the code. And obviously, we have the bandwidth over here for the internet. Okay, so the beauty actually of the Tessel is that as well, I don't have a slide for this, I'm sorry, but we have a lot of modules that we can use in order to experiment. So I will definitely suggest everyone to have a look at their website. They have the Tessel, they have a lot of modules that we can buy or we can get access to relatively cheap in order to perform a lot of experiments such as accelerometers, also the moisture thermometer as well, lights. So it's plenty of things to experiment with, especially for beginners. It's very, very useful. So moving on this one as well, let's talk a little bit about my experience with it. So let's assume that everyone here would like to start a little bit of IoT development with me. The first thing obviously to know is that I'm running a particular setup here. I have optimized everything so to run on Ubuntu 19.10, even early, and using Node.js 12.8.1. In particular, this is my software of choice specifically, but I will suggest everyone to check for your own, for the better version for Node.js that works for you, because for me as well, not all versions work, so I settled for this one, it works the best. So yeah, especially if you're running on an operating system. And so obviously if you want to start a new project, let's open a new, let's actually create a new directory, name it whatever you want. Then you have to start the project itself, so run yarn init, or if you prefer npm init, and fill out all the information. Following, obviously, still and we have to add the dependencies, in this case, Johnny 5 and the Tessel IO. We're going to need them later on. And then, obviously, we have to install, if you didn't already, install the Tessel 2 command line interpreter. In this case, I decided to go and install it globally, so that I don't need to reinstall it every time I run a new project. And that's basically it. So this is what you need to set up your environment and start experimenting with JavaScript and IoT. And if you did everything ready, by calling T2 list in your terminal, you'll be able to see something like this. Yep. So yeah, it's quite awesome, especially the first time you run it. As you can tell, obviously the name is not exactly the most memorable one. So T2 actually accepts many different commands. You can also run T2 name and set up another name, the name that you prefer, so that it can actually be, you can assign a name to your Tessel that is more memorable. And so yeah, so first experiment after setting up everything, and here you go, first experiment that I performed. So this is a little circuit. This is the blueprint of the circuit that I built. Real quick. I think it's necessary to explain. Please stay with me. So this tool that you see at the bottom, behind everything, with a lot of holes, is called breadboard, and this is incredibly useful if you want to start experimenting, because this is what you're going to use to create a lot of different circuits. And obviously, it's reusable all the time you want, and it's great for experimenting. These are all jumper wires that connect the Tessel to the breadboard in order to pass the electricity. These are resistors. Resistors are useful in order to keep the flow of electricity under control so that you don't burn down everything. And here we have LEDs, different colors. So LEDs have two legs. The longer one goes inside here. Goes on this side, so that because it receives the electricity, and it's called anode. And then we have the cathode over here that actually goes into this little channel. This is actually the discharge channel. And it's really important to set it up in this way, because the opposite way, well, it wouldn't work. And finally, obviously, to close the circuit, which is quite necessary if you want to work, if you want it to work. It's it's the ground jumper wire that is connected to the ground port on the Tessel. Yeah, so, at the beginning, obviously, this is a picture that my wife took of me when I was experimenting with it the first time. And I had a lot of fun doing it, and I think that experimenting is the best way to learn something. And if you do everything correctly, in the end, you will have something like this, running the program, obviously. And it's quite cool. But obviously, with this project, I was only able to tell the Tessel to run it or not to run it. I didn't really have a lot of control over it, and this wasn't really what I wanted to do. It was nice to see, but it wasn't really effective. Me as a developer, I wanted to have more control over it. Maybe through a graphic user interface. So yes, this is why I decided to go over a little bit. I built basically another project, which I'm now going to demo. So excuse me a little, I need to say that. Okay. So this is the Tessel. As you can tell, it's quite small. It's not really visible. But no worries, have no fear, I have here something to help. This is the graphic user interface that I built, and now we are mirroring my phone, and this will help you to see what is happening. So, you're going to see, okay, so what happens if I press a button? Maybe green, boom. And it turns on. And I want to stress this, but basically what I did, I built a web server on top of the Tessel, which is now running, and it is not connected to my computer. It's all running wirelessly on the internet. So I can toggle. I wish I had another hand. I can toggle. No. I can toggle any color you want. Just please scream me a color, and I'll turn it on. Purple. Yellow. Purple, yellow, yes. We can do that. Purple, yellow. It's a little bit fading, but it's there. The LED is not doing correct. It's not doing well. I experimented a lot with it, and the yellow is not working correctly. So yeah, it's nice, and I can also drag buttons. If I click them again, I can turn it on and off. I can drag them and drop them on the Tessel image here. And in general, if I then click on the Tessel, as an Easter egg, boom, there we go. Yay! A little bit of colors. It's quite nice, and we can also speed it up. Yay! There we go. A little bit of disco now, and we play the music and we dance. So, okay. I'm gonna let it on, but I'm going to turn off my phone, and we can continue a little bit, so you can all get distracted and not pay attention to what I'm saying. So, this was a very quick demo. And I built it basically in one day only. And this is like a proof that will tell you how easy it is to start developing IoT devices or wannabe devices in a very quick time, even if you don't have experience with it. And for this experiment, the technologies that I decided to go with for the front end, I decided to use React, and obviously the Johnny 5 framework and the Tessel firmata. While for the backend, which was a little bit trickier, I decided to use Express to run the server, and the communication between the client and the backend is actually done through socket.io. Apologize, there is a name here. Socket.io is another framework that is used to make the front end and the backend communicate, and it's event-driven, so you can toggle it from both the backend and the front end. So yeah, so we are reaching the conclusion of my tech talk, and oops. Here we go. So if you have to remember anything from all of this, of what I said, I know there was a lot to process, a lot to remember, but if you have to remember something, obviously remember that with IoT, These are devices that are connected to the internet and they can be controlled through another device. And in particular, there will be more and more devices connected to the internet. This is the future. And Johnny 5 and Tessel 2, they are an easy way to get into programming IoT while using a friendly programming language such as JavaScript. And finally, obviously, well, that it's very nice to experiment, and it's the easiest way probably to learn something, and I will suggest everyone to do so. So thank you very much for your attention and for your time. These are all of my contacts. You can get my GitHub here and my email. And please connect with me as you will, as an IoT device will do with the internet. Yay! Thank you.